Hello everyone, for First Updates Now, I'm Tyler Rolls and you're watching Behind the Bumpers, this fun show where we dive deeper into FRC robots and what makes it work. And today I'm here with team number 2481, Roboteers out of Tremont, Illinois. 2481 has been a personal favorite team of mine for over a decade now, creating some of the most innovative machines in FIRST. This team burst in the spotlight in 2014, taking their first regional and championship division win. They would go on for additional success in 2016 with a World Championship win, and also have a total of 10 regional wins, 4 finalist appearances, and a Chairman's Award, and in the 2021 Infinite Recharge at Home season, won the Chromium Group. Their 2020 robot never got to see the light of day in person at competition, but if you have played the second Robotics competition simulator, this is one of the cool robots featured. So we're going to be going into both their 2021 and their 2020 robot in this. And today I have Josiah, Jonathan, and Andrew, and I can't wait to talk about these robots. As mentioned, personal favorite team of mine. Both these robots, cool strategies behind it, all coming up here on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker is a leading medical device company and is looking for those in FIRST to join their team as interns or for a great career. Come join a company that will actively support you being in FIRST at careers.stryker.com. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. So Josiah, we're going to start with you talking about the 2021 robot here, and you guys took a really interesting approach. We've seen only a couple other teams do this, and I love the simplicity of going to this where you pretty much is a robot with an intake. So I'd love to hear more about the strategy behind this, and of course some of the intricacies that go into this really cool machine.
Yeah, that's a great question. So we started this season off how we usually start our season by evaluating, looking at the rules, reading the rules, and then from there, we discuss what is the best way to maximize points and then win. But then we also saw that there was an opportunity. If you built a very fast robot, you wouldn't have to put a shooter on at all. And so you have the ability to go super fast and be potentially faster than the robots that did have shooters. And so we decided as a team that the way to potentially win would be to not shoot and to just intake balls and make a very fast robot. And so to do that, we realized that on the Galactic Search, it was paired really well for 2 intake setup. And so we decided to design it like that. So right now, we took off our different springs that would flip our intake down, but we had a pin that pulled out, and then both of our intakes flipped down. And that's how we started each Galactic Search. And we also took off our netting, which was actually just duct tape, but that's how the ball stayed in without not falling out.
I love that you mentioned that the netting is just duct tape, by the way. So, looking at this from this dual intake, we've seen robots do dual intakes, but usually it's like a front or back or something like that. Looking at your Infinite Recharge at Home, you can see the benefit that you have of that, but how did you come up with it that you should have it on a 90 degree versus it being, 180 from each other?
So when we were first looking at the rules, we saw that on like the different paths, it was really paired well just to spin your robot slightly. And since we love to do swerve at 2481, we thought that the dual intake would just be perfect just to barely twist our robot to be able to pick up both balls fastest. And if we had it 180, you'd have to do a full 90 or maybe a 180 turn, which is not really ideal when you're trying to get fast times.
You brought up a great segue speaking about your Swerve as well, too. So let's go over to Jonathan, who's going to talk more about the Swerve on this robot. And then we'll be going into 2020 robot as well. But Jonathan, tell me a little bit more about the Swerve and the programming that goes into this robot. Anything you want to touch on from that aspect?
Like most years, we decided to go with a Swerve Drive. And this year, we decided to use Pure Pursuit to follow a path. So for autonomous, we decided that we would generate paths, like for the Galactic Search, and then follow those paths to collect the certain balls. And what goes into doing that is you can have slip and all these other errors that can occur. So we use odometry and adaptive pure pursuit, which allows the robot to look ahead in the path and course correct to make sure it stays on target throughout the autonomous venture.
Is that how you compensate for drift with odometry? Because that tends to be a bigger issue in FRC than FTC, is how much drift you get out of that. So is that what pure pursuit is really doing?
Yes. So it allows us, so if we do get off target, it will command the wheels, creating a vector back to the target position, looking ahead a certain distance based on our speeds.
So what is your top speed on this robot, and could you speak to the gear ratios at all? And let's take a look at those gearboxes too.
Our top speed beforehand was around 250 inches a second, and that's more theoretical and not much field testing with it. And then we did some testing, and we found similar results to that. And then when we did the gear change, it went down to about 210 inches a second.
Well, let's go into the 2020 robot. I mean, 2020 robot, absolutely fantastic. But your 2020 robot is something that I really wish we had an opportunity to see more of it. And you never know, we might still get a chance in an off-season competition later on in the year to see something like this. But this robot is just absolutely outstanding. When I saw the reveal video come out for this, I myself, and I'm sure many others, were completely floored by the concept of this robot that you have. So let's start out with the Swerve on there, and then we're going to take us through the power cell journey as well. But let's start out with the Swerve here, Jonathan.
All right, so the Swerve is pretty much identical in the sense of coding-wise and pure pursuit, but we do have, because this one has to be able to shoot at a target, we use motion magic to command the wheels to certain angles and then drive an arc length, which allows for faster rotation speeds and more accuracy with very little error that you can get with PID. And with that, we were able to quickly turn to the target for shooting purposes.
Can you talk a little bit more what motion magic actually is? And then speaking about, both that and pure pursuit, for a team that's never done that before, what would it be like to actually get into using something like that?
So for our team, what we did for motion magic is we command the wheels to go to a 45-degree angle, and we calculate the lever arm, which is basically the radius of the robot, using Pythagorean's theorem, using the half the length and half the width of the robot. And with that, you can calculate your radius and calculate an arc length for your robot to travel. And then you tell the wheels at the angle of 45 degrees to travel that arc. For pure pursuit, we do it a little complicated compared to most teams. But for a basic overview, what you want to do is when you have a pre-programmed path and an odometry that works, that can be able to detect and keep track of your position throughout the match, what you're going to want to do is you're wanting to calculate a certain distance you want to look ahead based on your max speed. And then if you ever, as your robot's going along the path, you look at your position and the position on the path you're looking ahead, and you use the simple trigonometry to create a vector to intercept that new point on the path. And obviously, if you're following the whole path, you're going to continue to look further and further ahead as you're driving along the path, and it will automatically course correct over time.
Well, Jonathan, thanks for telling us a bit more about the Swerve on your robot, on both these robots. Obviously been a very integral part of your machines. Next, we're going to be heading on over to Andrew, who's going to be taking us through some of that power cell journey, starting with the intake of the 2020 robot and going into the indexer as well, too. As then afterwards, we're going to go into this gigantic shooter that you have, but it all starts with the intake. So tell me a bit more about that.
So we decided that we needed an intake that could pick up multiple balls at once because it seemed like the field was always full of a mess of balls. So we decided to make a full-length intake, and that's pneumatically actuated, and it's got a bunch of black wheels that we decided gripped the best for running over the bumper. Then the ball will run down into this dungeon trench here, and then in through here, which is kind of a indexer. And then we've got multiple beam breaks in between all along the indexer that space the balls out so that we don't smash balls in between each other, because that causes the intake to jam and could potentially ruin a match for us.
So let's keep moving on into this shooter that you have here. Obviously, a very innovative approach to literally take a bicycle wheel and do this. But, you know, the have this where you're able to shoot, you know, from a massive distance versus what we've seen almost any other team in the field do. I'd love to hear a bit more about that, Josiah, in regards to what was the concept even behind this in the first place. And then let's go into some of the guts of it as well.
Yeah. So I'm just going to talk about kind of like how we came up with the bike wheel, because I feel like that's like one of the biggest questions about this robot is how did you come up with this? And so after our initial like walkthrough of the rules and everything, we just thought that the best way to score points would be to shoot from behind the control panel. And so we spent about 6 weeks prototyping flywheels, more of like a double, or like a rifle shot that some teams have, like a lot of different types. We even came up with this like washing machine design where it would kind of spin and then shoot them out. But eventually one of the mentors brought in like his bike wheel that he just had at his house and decided like, let's try this. And we continued to prototype with it, and it continued to be really accurate and be very good with the ball variation. Because a few of the designs we had could shoot all good balls really well, or maybe all bad balls really well, but we couldn't really get one that really shot the good and the bad balls really well. And this is the first design to do it. And then from there, it was a bit of a struggle to find the right bike wheel and the right rim for the bike wheel. And so actually ours is a bike wheel rim with a handicap chair as the wheel as the outer, and they both work well. And why it's orange is so that it doesn't mark or anything to the balls. And then how it actually works is we have 3 Falcons powering it, and we have 1 flywheel. And so with the 3 Falcons, it gives it enough power to really speed it up fast. And then the balls just travel up through it, and then this tube up here is a little, like, it looks like it when it makes sense for it to be curved outwards, but we actually found that it actually brings the balls into the middle versus making them, so it helps center it, and then it just shoots. And then you can also see that we have this Lexan piece that flips up and down. And because of the way the bike wheel is, like the geometry of it, it can't really shoot close up. So what we did is we put the flipper up, and it ricochets off the flipper and pretty much in, which is pretty cool.
And then do you know what your compression is on the balls that you're putting as it goes through that shooter?
I think it is, I think if the balls were 7 inches, we're shooting about 4.5 or maybe 5.
Oh, wow.
We definitely compress it a lot.
Yeah, no kidding. So how long does it actually take like your shooter to get to speed? I know you got, you know, three of the motors on there, but with it being so large, how long does it actually take to speed up for a shot?
I would say about 2 seconds. It might be closer to 3, but it's pretty fast for being so big.
And because you have so much momentum, you can just shoot rapid fire essentially, right?
Yes. And that was one of the big things we were going for, is not to have any decrease in speed. So that's partially why we have the 3 motors and the flywheel on it.
Let's wrap up the robot here, talking about the climber on there. So Andrew's going to be covering the climber that you have in the robot, and then we're going to end up wrapping up.
So our climber is a fairly basic piece of equipment. Basically, this long tube here that travels the entire height of the robot extends via a chain and another Talon motor, and basically raises up to the height of the seesaw, and then it balances very well with the height it is, and then when we come up, it pins it in between this these two of metal and then this as well to clamp it down together so that it's not swinging to keep everything stable.
Thank you so much for taking the time to speak with us about your robots, and really wish you the best of luck in the future. Can't wait to see how these robots hopefully perform even more. Of course, your 2021 robot already winning in its group. Hope to see a 2020 robot performing as well. Thanks for taking the time, guys.
Thank you.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.